Hello, everyone, and welcome to the next session of the Data Track of Dev Days Europe Conference 2022. I hope you enjoyed yourself and enjoyed also the speakers and the interesting topics that we had. And stay with us because we have prepared lots of interesting things to come, and you enjoyed more, I'm sure. And the end of the session, just to mention, we'll have some Q&A time, around 5 minutes. You can freely post your questions in the Q&A section, and at the end, Nathan will be answering them. Keep in mind also that our Knowledge Partner Pact will be giving away 20 ebooks to the most active conference attendees. So we kindly urge you to participate and be active, rate sessions, leave comments, ask questions, and you can win a great ebook. Okay, let me introduce you now our speaker, Natan Silnitsky. Natan is a backend infra team lead at Wix.com, and Natan also leads the data streaming team in charge of building event-driven libraries and tools on top of Kafka. Before that, he was part of a task force that was responsible for building the next generation CI system at Wix on top of Google's Bazel build tool. Nathan has also many years of experience as a developer of large-scale web services. Nathan's passions include clean and functional code, dev velocity, and great software design. His topic will be Kafka-based global data mesh at Wix, very interesting one. And in this talk, he will talk about Wix Kafka-based global data architecture and platform, and how they made it very easy for Wix 2000 microservices to publish and subscribe to data no matter where they are deployed or what technological stack they use. I'm leaving with Nathan. Enjoy yourself. Nathan, I'm giving you the stage.
Thank you so much, Emil. And I hope everyone can see the slides as well.
Yes, we're seeing the screen.
Great.
Thank you.
So welcome everyone, and really excited to be with you today. So like Emil said, I'm going to talk about Wix's Kafka-based global data architecture and platform, and how we made it really simple for Wix's more than 2,000 microservices to be able to handle our ever-growing traffic needs and scale, but also keeping track of fault tolerance and in a resilient manner. And these services we tackled no matter where they are deployed in the world, and no matter what technological stack they're built on. So completely decentralized data processing in event-driven fashion for all of our microservices. I also talk a little bit about tools and features that we have created in order to make sure that we keep tabs on our ever-growing scale, both in terms of developers and in terms of traffic, and do everything in a resilient manner. So first, a few words about Wix. Wix is a website building platform, a very powerful one, and that allows you to also manage your business online. Our mission is to enable any business, community, or person on earth to make their online dreams come true. And we have around 5,000 people working on making those online dreams come true. And we serve more than 100 million websites for our Wix users, which is roughly 6% of all internet websites, which is around 1.7 billion worldwide. And we have more than 1 billion unique visitors that visit our Wix platform, websites, and also mobile apps every single month. And the scaling concerns at Wix are really quite huge, more than 500 billion daily HTTP transactions, with GA more than 600 times a day, with more than 1,500 developers, etc. So scale here is very massive. And we have more than 2,200 microservices in our environment, which work a lot with event-driven style of programming and data processing work as events are being consumed by a lot of these microservices. And as you can see, the numbers here are also quite impressive. 70 billion daily produced events all around the world in 4 regions, with around 50,000 topics and 500,000 partitions, while a lot of this data is replicated between the regions. And we assume tenfold increase uh, in this scale in the next year or two. So quite challenging distributed environment. So the topic of this talk is how we tackled this growth in a decentralized data mesh kind of style, right? And so we kept things simple for Wix developers, even as the environment itself become very complex. And as I mentioned recently, in the last few years, Wix microservices have partially migrated to event-driven architecture, and which means it created a distributed environment, a very highly decentralized one, where events are produced anywhere and consumed anywhere, with complete decoupling between them, and with very large scale traffic. But not only a lot of traffic, also the whole notion of having hundreds upon hundreds of developers working in this style in all kinds of technological stacks meant that we needed to create a messaging platform that will have this universally solved for our developers and enhance and have them be able to use a lot of standard features all across Wix in order to connect to this data mesh. So we created our own platform and called it Greyhound, and we'll see how it helps developers at Wix. And also, we tackled two more very important topics in our ever-growing scale. One of them is that in each region, we had a single Kafka cluster for microservices, events, communication, which really became overloaded, and we'll see how we solve that. And another thing is when you have so many regions across the world, you want to not need to think, okay, I'm a producer of this event. Where does this event need to be consumed? Who is going to consume it? Because that breaks decoupling. So we'll talk about the work on how to have this global decentralized view of data processing, and that doesn't need to have this knowledge of I'm producing, where are my consumers. So first, we'll start off with Kafka-based event-driven architecture. Basically, you probably know Kafka. We have Kafka producer produces to the Kafka broker, and then we have other services that consume from these Kafka cluster, and they produce to a specific topic, and then this topic is divided into partitions. So actually, the producer produces events to a specific partition. It does it, writes it sequentially, very fast to basically a commit log. So it's not a queue like RabbitMQ. It's a it's a file that append stuff sequentially to the file and also work in memory. So it's really fast. And then we have the Kafka consumers that from could be various services that consume the messages. And it's not like they remove messages from a queue. It doesn't work like that with Kafka. They just scan sequentially each of the partitions. And once they finish processing some event, they mark this offset in the partition as committed. And if there's some restart, they know where to begin next. So this offers a lot of resiliency, and Kafka itself is a very resilient platform with replication of partitions across multiple workers, and really easily able to scale stuff. We just add more partitions that you can produce and consume from. And so we knew that Kafka has to be the heart of our ever-growing event-driven architecture because it's really efficient and scales really well. But we knew that the Kafka SDK itself will not be able to give us a true decentralized data mesh. So we actually created our own library at the beginning where we called it Greyhound, which is also open source. And the basic tenet of Greyhound is that it wraps the Kafka SDK. So Greyhound producer wraps Kafka producer, and Greyhound consumer wraps Kafka consumer. The idea here at the beginning was to offer an abstraction layer that will be offer a transparent data processing, event processing solution for all Wix microservices, and do it in a seamless manner. So if Kafka is upgraded, it's automatically propagated to all the microservices, bug fixes, etc., and also new features. Everyone can get them really, really fast. So the basic API for Greyhound is to create a Greyhound consumer with a group name, a topic name, and the message handler, which is basically the Lambda, the specific custom processing code that you need for the specific event. And on the other side, we have the producer, where you just spin up a producer and it just you're able to produce. For Wix developers, they don't need to think about the don't need to configure the addresses of Kafka. It's really a high level concept here across the board in all the services, and really, really fast bootstrapping. Now, which features our developers can enjoy? So the first one is parallel consumption. So developers can actually constrain or increase the amount of parallel work being done in each of the Kubernetes pods or service instances. So you can think about maybe you have a slow database or some slow third party that you want to constrain the amount of parallel processing you do, even if you have a ton of Kafka partitions. So you just specify with Greyhound a smaller max amount of parallelism. Or if you actually have very high throughput traffic, then you want to have as much parallelism as possible, like with all the amount of cores that you can use in order to have better performance, right? So the maximum, of course, is parallelism across all pods is the amount of partitions in Kafka. So if you want to even have even bigger parallelism than the amount of partitions, you have to first increase the amount of partitions, but then all pods, but you can have a lot less pods than partitions and still gain all of the parallel work because you have more cores working on it. And it's really straightforward. You just specify a value and your Lambda handler works for you in a parallel fashion, which is cool. And then we have batch consumer. So there are cases where you want to work faster and you have the advantage where your processing includes third party or second party bulk APIs that you can utilize. So you can actually work on events in big chunks and have it uh, then later on call some bulk API, which is really much more efficient when you work with very high scale. And other aspect, of course, is the resiliency here. So we have such a decentralized, big system, and you want to make sure that processing eventually succeeds of events. So Greyhound offers various kinds of retry strategies. So you have non-blocking retry strategy in case that order doesn't matter, and you eventually succeed after 1 minute or even 1 hour, 1 day, if in case it's some job that you want to run in the background, and that's okay. Or if all those retries fail, it goes to a dead letter queue so you can investigate and you can also replay the message. And resilient producer. Resilient producer means that you can use Greyhound safely and know that even if you have connectivity issue with Kafka, it won't bother you because the resilient producer knows how to back up the data and then have a mechanism to send it to Kafka once connectivity resumes or some configuration is fixed. So before Kubernetes, we actually saved the messages to disk before sending to Kafka. But now what we're doing is with Kubernetes, if Kafka for some reason fails to produce message because some networking issue, like I said, or the cluster is even down, God forbid, then messages are sent to a distributed managed key value store or object store if the message size is too big. And then there's a dedicated service that knows to produce the messages it finds in the object store to Kafka. So we lose ordering, but we're guaranteed that messages will arrive to the consumers eventually. And we also have context propagation feature, meaning that as a user request flows through the distributed decentralized system, um, all the user request contexts like the geolocation and the language can propagate, no matter if you're going through HTTP, RPC, or Kafka. You can make sure that you have all of that context propagated all around the microservices. And also matrix reporting. So Greyhound offers unique metrics that are not found in the Kafka level. For instance, what's the average time it takes to handle an event, or the 99th percentile of handling time? What's the current longest running handler? Maybe something is stuck and I need to look at the message. So there are a lot of very important metrics to debug the event-driven distributed system. Now, first Greyhound was created as a JVM library, but then as Wix grew, there were more requirements to actually have microservices in non-JVM languages. So we have a lot of Node.js services, but also Python and Go. So in this case, we created Greyhound as a service, which usually runs as a sidecar container next to the container of the node application in the same Kubernetes pod. And the node application has like a framework, a standard way to interact with Greyhound as a service via gRPC and protobuf. So Node.js application developers have a seamless experience working with Greyhound, but behind the scenes, it actually calls gRPC and calls the sidecar. And we also have other setup of Greyhound as a service, but I don't want to dig into deep in this area. Now, having this Greyhound layer meant that there was event-driven tool to be used across all microservices at Wix, no matter which technological stack they are built on, which laid the foundation to a complete ecosystem around events. So, for instance, we have libraries and mechanisms that allow to very easily send out domain events whenever something changes in a database. We're also working with the Bezium to have it completely automatic. And we also have, of course, extraction using Greyhound and putting it into the data warehouse and data lakes. And that can be done on any service automatically discoverable and any service events emitting. And we also have task scheduling on top of Greyhound, which utilizes Greyhound and Kafka to have the ability of any microservice at Wix to do task scheduling. And also asynchronous job queue internal for each microservice to handle, also on top of Greyhound. So there's really a huge ecosystem of stuff around event-driven style programming in order to help Wix developers make their life easier when they work in such style. Even though they have many microservices and a lot of data going back and forth, they can still manage it quite easily. Cool. So we talked about Kafka, we talked about Greyhound, and the ecosystem above Greyhound. Let's now talk about two very important blockers that we solved at Wix. So the first one is having cluster overload. So like I mentioned, we used to have a single Kafka cluster per data center or region around the world. And it doesn't really make sense to share clusters around among data centers because of there'll be much higher latency, of course. So in each data center, we had all of the partitions for each of the topics. And because of our scale, it grew to be far too big to handle in a single cluster. We really reached the limits of what a single Kafka cluster can do. So we decided to switch over to a multi-cluster environment. So each data center can have more than one cluster if needed. And we split up clusters according to uh, specific user flows. So in case you have a flow where you're editing a site, publishing it, managing your back office of your business and setting up stuff, all of that will have flows in one cluster. But for flows relating to a customer visiting the Wix site and paying for stuff there, or just browsing for stuff and interacting, all of that happens on a different cluster. So this way, we can really limit the blast radius for our different Kafka clusters if something goes wrong. But now we have our decentralized system, and we want it to be simple and straightforward for developers to produce and consume from the correct clusters. So we decided to have like a logical cluster concept. And when you work with the consumer, you just specify on which cluster the consumer is working on. The same thing goes to the producer. So no need to think about how to connect or stuff like that. It works out of the box. And we are thinking about how to auto-resolve clusters, but that will mean that different clusters will probably need to have um, unique, uh, a topic name will need to be unique across all clusters, which is kind of a limitation we may not want to have. So we're thinking about how to make it even more central, how to make it even more transparent in our decentralized system. And of course, you need a lot of self-service in order to work in a decentralized data processing environment. So when a developer wants to know to which cluster they need to consume from, they can go to our Kafka control plane, our Greyhound control plane, and look up a topic and see on which cluster this topic is provisioned, and then they can simply consume from it. Okay, so we got multi-cluster environment that we're pretty pleased with for our data mesh. Now, let's talk about the blocker of having the need to know where our services are deployed, in which region. So think about the current use case. We're currently running on some service in some data center, and we happen to run on a data center where there is no write-enabled database cluster. We only running in a data center that has the read-only replica of the data. So we can't write here. That means that we need to actually consume the event not in our local data center, but in the remote data center that actually has the ability to write to a database. So now we'll go through some cross DC services that we have and Wix infrastructure layer in order to help with the situation with higher and higher level of abstractions and ease of use. So the first way is that the developer needs to specify the geo-replication that it wants to happen for each topic that it owns and produces to. So where it thinks consumers will need this topic. And that's quite low level. A higher level abstraction is if you know that your consumers um, need to write to a database in the main data centers at Wix, then you can specify Greyhound to always produce to the main data center, and we'll see how to do that. But that means that at Wix we'll need to always have the idea of this is the main data center. It's hard coded, and or this set of data centers are main data centers and can have potentially write databases. But we want to have a much more flexibility in our data centers and have it less rigid. There's also all kinds of regulations for where data can be kept in the world, and we don't want to be too constrained here. So currently, we're working on being able to just produce an event, and if a consumer in some part of the world needs it, it will get it seamlessly. And we'll see how we're currently implementing that. So let's see the lower level application and how that works. Basically, we have a Graham producer service with a Graham producer in one data center. And there's actually a replication policy set um, that requires to replicate this events from DC1 to DC2. So our custom built replication service actually utilizes Greyhound batch consumer, which is much more efficient here. And then it consumes the topics that have replication policies, and it knows to route them to the correct data center according to the replication policy. And it uses uh, optimizes the Graham producer to produce with big uh, chunks of events. And this way we can keep really high throughput for replication across data center. And then the consumer in DC2 can consume the message and do whatever it wants with it, write the event to database or something like that. We actually use Kafka compact topics for saving and storing the replication policy, because then with help of Greyhound, we can actually load the compact Kafka topic that you can think about as a key value store. We load it into memory and we have zero latency retrieval of the policies, making it really fast to get updates on new policies and work accordingly. And this is the view in our control plane where a developer goes and selects for a specific topic which replication policy it requires. So they can choose to replicate the topic among all data centers or just between the main data centers currently, or some custom rule where they subscribe a specific data center to which to replicate to. Okay, so this is quite low level work that can be a real hindrance at times. And now let's see how we implemented produce to main DC. So reminding you that only some data centers are defined as main data centers with the option to write to database. So if we have a Graham producer in partially in data centers that have only replicas of the database, then they specify Greyhound with the config to main DC. And what happens then is that behind the scenes, the event is not actually produced to Kafka. It is produced by a gRPC call to a main DC producer service that has a gRPC endpoint. And this service knows to get traffic only to the main data center and active data center that it's currently deployed to. So actually, with HTTP routing rules and the gRPC message can go to the correct data center, and there the main DC producer service produces the message to Kafka. And so consumers in DC2 can they go and process the event and write to the database in the correct data center. Okay, cool. So we talked about how to produce to the main data center in a really straightforward manner. But still, like I said, it really is quite complex rules and really constraining our regions around the world in what are their function and what they are capable or not capable to do. So we want to really streamline that completely and not worry about where consumers are found. So this is currently work in progress. We're actually working on it these days, and we are we have the um, our replication service version 2 that actually follows the topology of each Greyhound consumer. Where is it deployed around the world? So it keeps track of state of consumer deployments. So because we have Greyhound deployed in all our microservices, they can actually emit their own special events on where they are deployed right now. So that can be sent over all the time. And then the next generation replication service now can keep track of that and then say, okay, is there any local consumer that can consume the message, the event? Okay, so probably don't need to replicate it because a consumer is found locally. But if there is no consumer found locally in this specific region, let me go over the uh, consumers were in other regions and find the closest region to me. And then um, the replication service will replicate the data to that data center where the consumer is actually deployed. Because if it's deployed there, it means that it wants to process it. And we're also working on having filtering done that only the correct consumers will achieve the ability to actually consume data. Yeah, so like I mentioned, the replication service um, will replicate only to consumers that are actually only to data centers where consumers are actually deployed. And what this does basically, it reintroduces the decoupling between the producer and the consumer, because like I mentioned earlier, you can if you work in the request reply style, you always know the server that you're calling. But when you work in event-driven style, you don't, and you produce some event, you don't really care who are your consumers. So in this way, we gain back this decoupling and the more robustness of our decentralized data mesh. So the concept here with this work that we're doing now is to have a single logical Kafka cluster to work with for our developers and not worry about the different regions. So to summarize, with the help of our Greyhound messaging platform, any developer at Wix can work in the event-driven style manner and process data, no matter on any technological stack it works in, and anywhere in the world that it deploys, it just works. And like I mentioned, Greyhound is open source, so I highly recommend for you to go and check it out. And with almost all the cool features that I mentioned are part of the open source version as well. And I would like to thank you very much. You can actually find all the slides from this talk on SlideShare and this link and all the other links. And I also highly recommend for you to check out my website at natansil.com in order to find previous talks I gave all around software engineering, event-driven architecture, Kafka, caches, key value store, stuff like that. And you can also follow me on Twitter and LinkedIn in order to see all that our info team is up to at Wix all around these topics. So thank you again. And I would really love to take questions if you have any.
Thank you, Nathan, for the great call, for the great presentation. For it was very informative. There is one question from Vilius. He's asking, is there any plans for Greyhound API to support more languages?
Okay, good question, Vilius. So currently, Greyhound only works for JVM languages. We have support for Scala and Java there, and Kotlin users usually use the Java version. And what we hope to do in the mid to long term future is to actually have the Greyhound as a sidecar concept, uh, to have the Greyhound as a service concept, to open source that. So you'll have like a Docker image that you can set up by yourself and communicate with Greyhound via gRPC protobuf protocol. Um, but we need to have the Greyhound logic sit on top of an open source web service, basically gRPC service, and not have any private Wix code there. So it's going to be a work in progress, but that's definitely one of our plans. So and then any language can use it, basically.
Thank you for the answer, Nathan. We'll be waiting a couple of more minutes to see if any of the attendees have more questions because we have 10 more minutes left in the session. If there are no more questions, we are going to wrap it up in a few minutes.
If anyone thinks of a question later on, they can hit me up on Twitter. I have open messaging, open DM for anyone to contact me.
So we will be available. Okay, so no more questions at the moment. Thank you very much for the great talk and hope to have you again with us soon.
Thank you, Emil, very much. I really enjoyed it, and thanks everyone for attending. Thank you so much.
Yes, thank you all attendees for attending that great session. We're going to make our lunch break now, so see you in the next one in the data track.